Okay, today I'm going to try to microwave sinter some, basically that's firing in a microwave, some clay glands that I made from some commercial clay. These were all around 70 to 75 grams of clay. The clay was kind of wet. They're now around 60 grams. The lightest is 57, the heaviest is 61 grams. And I dried them for a couple days. Tried one yesterday. It cracked because there was too much moisture still. So these four I dried in the oven for the last 2 hours, and we're gonna see the weights here. So, first one. Oh, it's rolling. That's fun. 56.6 grams. Next lightest one, I believe, is this one. Yeah, 57.1, 57.0. And then these two are 61-ish, if I recall correctly. Yeah, 61.3. And 61.5. Okay, so those are the weights. They're still a little bit warm. What I have is a $40 microwave kiln. And what this is it's just an insulated box basically with alumina castable insulation, and then I believe it's a silicon carbide absorber that absorbs the microwaves. And basically I'm gonna try, I'll see if I can get all four. I don't think I can get all four, but I'll try to do at least 2, maybe 3 of the glands, fire them, and then yeah, I'll do 3. I've done 1 before successfully. We'll try 3 and see how it goes. But yeah, we'll get these loaded up. So I'm gonna save the lightest one. So this is the 56.5. Don't want it touching the walls, because the walls get crazy hot. Like probably 1500 C at some points, maybe 1300, I'm not sure exactly, but they get really hot. And then, so I'm going to arrange these to try to get them not to be touching, and not to touch the walls either. Maybe get the butt ends all towards each other. Yeah, maybe that'll work. Okay, so arranged in there. Now I've done this before. I did some temperature calibrations already, and I think I have the process to get this to work correctly. But we'll try it out. So this is a 1200 watt microwave, as you can see here. It has an inverter, so it actually does do above 30%. It actually does change the power. It's not just the duty cycle, but below that, it's actually duty cycling it. So what I'm gonna do is we're gonna set the power level to the lowest setting, and then we're gonna do 5 minutes, let it heat. That gets it around 100 C, and then we're just gonna let it sit. Actually, I'm gonna do 3 minutes. 3 minutes gets it around 200 C. So let's try that. So 3 minutes. And so I took the turntable plate out. There's a piece of alumina wool in the bottom, like this stuff in the bottom, just to keep it insulated and keep it from spinning. And then there's also a alumina wool on this side to just try to keep the electronics cool. It does get pretty toasty in there. The kiln does a pretty good job of insulating, but it's not perfect. So I'm gonna do that for 3 minutes. I'll come back. I wish I could measure temperature, but it's a little bit too finicky to try to measure temperature, but after about 3 minutes it gets to about 100 C, so let that sit for a few minutes, and then I'll do the same power level for another 10 minutes. That gets it up to about 175, and then I'm going to bump the power level up to power level 2, which is 20% of the total power. That gets it up to about 300, 350 after 15 minutes. And so I'll just do 15-minute increments going up in power level to power level 4. And then power level 4, I hold it for half an hour, and that gets it up to 1,000 Celsius, which is about 1,800 Fahrenheit. And that should be enough to sinter this commercial clay. So we'll have this to compare size afterwards. But yeah, let's see how it goes. I mean, it's pretty. This is pretty boring to just sit here and watch, but it is good to sit here and listen, because sometimes you can hear it if it cracks, and that's of course bad. But since I dried these for the last 2 hours in the oven, I think they're fully dry. They lost about 10 to 15 grams of water a piece, so they should be pretty dry. Yeah, they all started out around between 70 and 75, and they're now sitting around, 56 to 60 grams. Okay, I'm gonna stop this and come back when we're getting closer to temperature. Okay, we're about 15 minutes total time. I started this after the first 3 minutes, but in terms of microwave time, we're at 12 minutes. And I just wanted to quickly show the dimensions of these. So this is the smallest gland. It's about 55 centimeters or millimeters long, maybe 54, by about 34, 35 millimeters wide. So it's got an aspect ratio of, what is that, 7 to 10? 10 to 7, I guess. Length to width. And it's about 56.5 grams after it was dried. We'll see after these get fired how much mass loss it has, but the first one I did was only a couple of grams. So we'll see. I'm just gonna leave this in time lapse, and you'll get to see this tick down. After this first run of about 20 minutes, I'm going to bump the power level up to 2, and then kind of take that real slow, do it probably 20 minutes on that, and then once I get to power level 3, we'll actually start to see the interior get hot. There's a hole in the top of that. There's a hole in the top of this kiln, and hopefully we'll be able to see that start to glow. But it's gonna be a while. Well, in the video, hopefully it'll be short, but for me it's gonna be another probably half hour at least. So. Okay, I'm gonna see how hot it is just by feel above this hole. Yeah, it's getting a little warm. I think I'm gonna do 10 more minutes of the lowest power just to make sure I've gotten all the water out, because it's the most critical step, is to make sure you've gotten all the water out before you start to ramp temperature. And then you still have to go kind of slow. So I'm gonna do one more step. I'm gonna keep my watch running so we have the total time, but I'm not gonna record all this. There's not much point to doing it, but I'll start recording again when I get to power level 3, where we should start to see a little bit of glowing, hopefully. It might not be till power level 4, but we'll see. Okay, just finished up the next 10 minutes of power level 1. I'm just gonna check the temperature. Honestly, feels about the same. Okay, that's good, I guess, I think. Okay, gonna go 10 minutes at power level 2, and then check the temperature. Actually, I'm gonna go 5 minutes and check the temperature. Okay, it's definitely warming up because I can start to smell the clay. I couldn't smell it before. Yeah. It's a little warmer of that little hole. Alright, we'll do 15 minutes at that power level 2. And we'll see when we hit power level 3 and start to see some color. Okay, that's 55 minutes in. That was 20 minutes at power level 2. I'm gonna... Oh yeah, it feels a little warmer. I'm gonna take a quick peek, make sure these didn't explode. So far so good. Alright. Cool. Power level 3. We're gonna do 20 minutes. Okay. Well, it's not glowing just yet, so we're gonna do power level 4. We're gonna go 30 minutes. Oops, keep missing. Okay, so we're about approaching 20 minutes left on the power 4. Let's see if we see anything. Oh, I think I see a little glow. Yep, there you go. A little bit of a glow there. So that's probably around 700, 800 C. Alright, well, I'm just gonna let it go. I was looking at my last run that was successful, and I only did power level 4 for 20 minutes. Granted, I only had one gland in, but I think I'm going to try. I'm gonna let this go until this is 5, and then I'm gonna stop it, and then I'm gonna bump up to power level 5 and go for 15 minutes, and then I'm gonna stop, and that'll be it. I am gonna cover the top here with a piece of this alumina wool, just to try to keep in some of the heat and also reduce the amount of heating to the microwave itself, because it's getting kind of warm. So yeah, I'll probably stop the video here and then open it up in the morning, and well, that's not true. I'll show what it looks like after I've finished the last run and what the temperature looks like out of the hole, and then I'll stop it, and then we'll open up in the morning and see how they look. Okay, here's the last 2 minutes of the run. I'll reach in and get the little piece of alumina off after this, and then we'll let it cool down and check it in the morning. The last run that I tried with this was at this power level for this long. It got up to about 1150 Celsius, a little bit higher, maybe closer to 1200, but it was kind of hard to tell. The thermocouple was bouncing around. That's toasty. I hope that didn't melt. Oh my gosh. I hope that didn't melt the clay. Look at that. Can you see that? That is nuts. Look how bright that is. It's really bright in the camera. It's actually less bright in person, but that's pretty hot, man. Yeah, the outside of this is probably like, I don't know, a couple hundred Celsius. I think that glow was coming from the inside and transmitting through. I don't think the glow is coming from the outside of the insulation. So, but yeah, I'll just close the door here and we'll check it in the morning, and hopefully they didn't blow up, and hopefully they didn't melt, because I have melted clay in this before. I'll show that tomorrow as well. See you tomorrow. Okay, it's the next morning. Been about 10 hours. See how this thing fared. I hope it didn't crack on the cool down. Well, I hope it didn't crack at all at any point, but let's find out. Oh, this look good. Wow. Can you guys see that? Yeah, there we go. Check it. Oh, it got a little too hot. Stuck to the insulation. Look how shiny this one was. He was right next to, he was facing the silicon carbide, so he got really hot on that side. Not so hot on that side. I think I got it to the point where I might have been vitrifying some of the clay. It was probably around 1200. But these look pretty darn good. Hear that? That's pretty good. All right, let's see. Let's compare these. So this was the fired one was actually a little bigger than this guy to begin with, and now he's a little smaller. Let's see what the dimensions are. I know I didn't measure the dimensions on this, but okay, so that's like 52 by 32. So it shrunk by probably like 4 millimeters ish. Okay, let's check the weight. Well, first off, let's just weigh this one again, make sure it didn't absorb too much water. I'm just curious. 56.8. I think it was 56.5, so it did absorb a little bit of water. And then this guy, I think he was one of the 63s. Or 61, I mean. So 57.2. Okay, let's weigh the other two. That's what you hear me doing, is scraping away the insulation. Okay, so what did I say this one was? 57.1, probably closer to, yeah, 57.1, that's probably good. This guy, oops, come on, don't roll. Ooh, 53. Oh, that lost a lot of weight. And then this fat one, 56.9. Interesting. Yeah, so these all lost like maybe 5-ish grams of, I'm not sure if that's moisture coming out, like adsorbed moisture, or if it's a little bit of mass loss from evaporation of the stuff, or maybe it's carbonaceous materials that burn out during the firing. But yeah, that worked pretty well. So yeah, microwave kiln works pretty darn well if you have the right recipe. That's the key thing, is being able to heat it slow enough so they don't crack, and then get in high enough temperature. If you look at sintering charts, it depends on the clay, but anywhere between 800 Celsius is about the start of sintering, so I think that's 800 is like somewhere around 1500 Fahrenheit. And then the sintering starts to melt for a lot of clays around 1200, unless it's porcelain, 1200 Celsius. 1200 Celsius is about 2000 Fahrenheit-ish. But yeah, these, I mean, so this is what it started off at. These are what I ended up with. And these are nice, dense little guys. I mean, these should go far. That was the intent, is to make them go far. So, yeah. I'll put the link where I found this kiln. There's lots of different knockoffs, or not knockoffs, but different brands that are all the same thing. But this one I think was $37 US when I ordered it. Seems to work pretty good. I've used it about maybe 5-6 times now. It doesn't seem to be degrading too strongly. The silicon carbide can oxidize. It can build up an oxide layer on the outside, but I think it kind of passivates, and it doesn't keep going after, you know, it builds an initial layer. Because I mean, it's been up at probably 1200-1300. I mean, you saw how bright it was when I was doing it last night. But yeah, here's a nice way to make fired glands at home. Relatively cheap, a little bit labor intensive, but you know, not too bad. I mean, I can fit 3 at a time. You could potentially build one that's bigger than that and do more, but yeah, I think you'd have to develop a little bit slightly different recipe, depending on how much you load it with. It's one thing, the clay materials will start to absorb microwaves at very high temperature. Probably not as strongly as the silicon carbide, but you will start to get like the heating of the actual material within the material once it gets hot enough. So you can have weird effects, especially if you're not rotating the kiln within the microwave. But anyway, yeah, it works. Works pretty well. Give it a shot. Just a quick demo on how dense these glands after firing are. So, oh, hey, that's a good transition. So, you can see that the outside. So if I soaked this for a longer time at high temperature, I imagine we would have got a better firing, better sintering in the middle. You can see that the outside is nice and dense, the middle's less so. And there's lots of little, I don't know if you can see that, but there's lots of little air pockets. And that's partially because of the densification. It's also partially, ooh, look at that guy. There's a big hole. Oh yeah, there's some air voids in here. So I got lucky these didn't blow up to begin with. But yeah, they're still pretty dense. I was impressed. These smaller ones seem to fare better in terms of the center. So yeah, and it's not perfect, obviously, but you could soak it for longer periods of time. I just wasn't sure if I was going to cause this melting, but because you can completely melt clay. I found that out the hard way. Okay, guys, there was just a couple more things I wanted to talk about before I sign off. So I mentioned melting clay as possible with the microwave kiln, and I wanted to show that because I thought it was really interesting. So here is a clay gland from Channing and Practical Paracord. It's out of Louisiana clay, so I don't really know what the composition is, but this is a fired clay gland. I don't know if you can hear that, but so he had one that was about this size that was unfired. He gave to me, and I thought, oh, I'll use the microwave kiln to fire it. And so I hadn't done any testing on it. I just went full power, about 20 minutes, stuck it in there, and it turned into this. So it went from this shape to this shape. So completely sagged, vitrified the surface, looks like a turd, and I took a hammer to it and broke it apart because I wanted to see what was inside it, but it went completely densified except for a few bubbles and just sagged. And so this probably got up to 1500 Celsius or something. So yeah, you can melt clay, and that's something you have to worry about when using the microwave kiln, especially when it's a 1200 watt microwave. I think, so if you're gonna use one of these microwave kilns, don't use your kitchen microwave. The one that I bought from Amazon, I think was about $37 or something, US dollars. It has a lot of weird binder smells that come out of it. So when they make it, it's castable alumina with the silicon carbide around, and it's got a lot of binder in it. And so when you heat it up, all that binder starts to degas out of it, and it smells awful. And you wouldn't want to have that around in your microwave and cooking your food. So get a separate microwave. I got a second-hand one for about 50 bucks. You can also, mine is 1200 watts. You don't need 1200 watts. You could probably get away with 800 watts and still reach centerable temperatures. So something from, this is probably about 50 bucks from, like say, a store like Walmart would work. You also don't need the power control like I have. Mine actually reduces the true power going in, the continuous power. But most microwaves, if you change the power, press power down, all it does is change the duty cycle. So 10% it's on 10% of the time, 50% it's on 50% of the time. That's actually good enough control from what I found, because mine doesn't do the continuous power control below 30%. So, and it worked just fine. It heated up nicely and heated up pretty uniformly. Well, relatively uniformly. So yeah, just wanted to add those few last notes, and if you're keen to make some sintered or some fired clay glands, this is a great way to try it, and it's relatively inexpensive. You don't need a whole lot of equipment. So yeah, give it a shot.